So I'm Neil Theise. I'm a diagnostic liver pathologist, a physician in New York City. I focus on the liver, and academically that's where my research started, and that led me into liver stem cell research, which led me into adult stem cell research, which led me into self-organizing systems and complexity theory as a way of describing what stem cells do in the body. And then that led to mind-body medicine type stuff, integrative medicine, and eventually to consciousness studies. Parallel to that, I'm a 25-year student. I'm a senior student at the Village Zendo in New York City of Enkyo Roshi Ohara, and have a pretty committed Jewish religious practice too, and a little bit of a shamanic thing going on. And it all sort of mushes up together. So I started getting interested in self-organizing systems, which come under the heading of complexity theory when you're talking about living systems, and some non-living systems. Complexity sounds complicated, but it's actually very simple. The complexity is how individuals, if there are enough of them and if they fulfill certain criteria, they will self-organize into larger scale complex structures. So the most common example we use to talk about it are ant colonies, because everyone's familiar with ants. So you have a bunch of ants running around, and no ant is really planning what's going on in the colony. The queen ant is serving a reproductive function. There's no planning going on there. And each ant is just paying attention to the local environment and signals from other ants, and in responding to those, they start to self-organize into food lines, into building a colony, into having a cemetery, having a dump for refuse from the colony, all sorts of higher level complex things that arise because the ants are self-organizing. How that happens is kind of mysterious, because it just seems to happen spontaneously in a bottom-up sort of fashion. But we all experience it when we're walking down a sidewalk in a busy street. And you see the way the currents of people walking down the street accommodate each other. You don't have people bumping into each other all the time. And the way traffic jams, for example, this wave sort of that develops in a traffic jam, comes from the way drivers in cars are looking at drivers coming in the opposite direction, it turns out. In LA, they discovered if they block the view at certain key points in the road so that drivers on this side can't make eye contact with the drivers on that side, an interaction between them self-organizes into this standing wave that we call a traffic jam. If you block that interaction, the traffic jam doesn't happen. So people organize themselves into neighborhoods and cities, into cultures. Jane Jacobs, who talked about how cities form, was really talking about complexity theory before there was that terminology. How people, the way they live in a city, create the neighborhoods in which they live. Ants are like that. And it turns out the cells of the body are like that as well. And so each cell in your body is not paying attention to what everyone's doing. There's no master planning cell that's telling all the other cells what to do. And they pay attention to signals from other cells. They pay attention to the temperature, the nutrient supply, all sorts of things. And in those interactions, out of those, you get the neighborhoods of the body forming, the different tissues, the different organs, etc. So that's how I started to get involved with complexity theory type things, thinking about how stem cells participate in the body as a self-organizing system. The terminology we use in complexity theory for these structures that arise are emergent phenomena, or emergence. And it does have a mysterious sort of mystical feel, because there is no one planning it. There is no one planning. I live in New York City, and on 6th Street there are all these Indian restaurants. The city did not zone Indian restaurants on 6th Street, or a flower market in the West 20s. but there they are, or that Wall Street would be downtown, or that the rich folks live on the Upper East Side. And yet that happened. How that happens, it just sort of happens. It's sort of tempting to want to say, well, there is some kind of guide to this, but there isn't one. It's not top-down. It's a bottom-up sort of phenomenon. Information is certainly part of it. And one can sort of look at the self-organization in a complex system as being a mode of processing information. What is that processing? Well, each member of the group, whether it's an ant or a person in the city or a cell in your body, is sensing what's outside, taking in that information, and then processing inside in what I would call a complex fashion. What that means is the processing of the information isn't like a machine. So a cell reads the environment and always gets, and then responds in precisely the same way. That's not what happens. If it was, then our cells would be machines and they wouldn't self-organize. But there's always some degree of randomness in every complex system. And this is where the creativity and the aliveness of a complex system comes in. So too much randomness in the system, you don't get any self-organization. Too little randomness, then the system, if it's machine-like, then the system will always self-organize in precisely the same way. And if the environment changes, it's not going to be able to change its self-organization to adapt. So that's a dead end. So you need a little bit of randomness in the system. And that's what allows for creative solutions and adaptation. So if you think about a food line of ants from a distance, you're looking down at it, it looks like a straight line of ants. But if you look more closely, there's always like 3 to 5% of the ants that aren't following the line. That's the quenched disorder, it's called, the low-level randomness in the system. It turns out those random ants or divergent ants are essential for the colony to be a creative, adaptive structure. If there's too much randomness, then there's no food line. Then nothing gets accomplished. There's no self-organization. But imagine that every ant is in the food line. Then when the food runs out, who's going to find the new food source? Or if a foot gets, if I put my foot down in the middle of a line, those ants are following the line. How are they going to find a way around the foot? It's those ants who aren't part of the line that rapidly find a new route around your foot. So this low level of randomness in the system is what makes things actually alive and adaptive. So let's say you have a cell. And the cell, let's say you have a paramecium that's swimming along, and it comes up to a boundary. Well, if you're looking at the paramecium, what happens is it will back up and then try again, shifting its direction a little bit, back up, try again, and it'll keep doing it until it gets around. So it looks like this paramecium is trying to find a route around the obstruction. What's actually happening is that the paramecium bumps into the obstruction and its membrane flattens. Now, the way a paramecium moves, it has these little hairs, flagellae, like little oars, that are all sweeping in unison together and propelling it forward. When the membrane flattens, there are calcium channels that open up in that flattened membrane because of the changing of the shape, and calcium starts to flow out of the cell into the environment. And that calcium tells the flagellae to reverse direction. And so the paramecium looks like it's backing up. The membrane straightens itself out again, and those membranes close, and the calcium sort of wafts away. Now, water isn't completely still. There's a little bit of movement in the water just because the water has temperature. There's Brownian motion. So the paramecium is actually being bombarded by the movement of the water. So now that's randomness in the system. And so now the paramecium is aimed a little bit differently. It's going to start swimming forward again, bumps into the wall, the same thing happens. So it looks like a process of learning and adaptation of actual sentience, but it's also something going on with the internal signaling because of what's changing with the calcium channels, etc. And the randomness is what allows the new behavior. So all of this, to some extent, is about information. The question I had is that, so you have a flock of birds can look like a solid thing in the sky. Sometimes you can look up, and if there are starlings going by, your first sense of a murmuration of starlings is there's this big black shape in the sky that's moving. And then you hear the sound and you realize, oh, it's a flock of starlings. And so it's not a thing at all. It's actually just starlings self-organizing, interacting with each other to create this structure. But if you go in closer to each starling, well, they're just a bunch of cells. There's no starling there. It's just a community of cells that are self-organizing into something that looks like a starling at this level of scale. But at the microscopic level, it's just a flock of cells. Well, if you go into the cell, what's the cell? It's just a flock of biomolecules floating in water at body temperature, which in part is what gives just the right level of randomness in the system. That's why body temperature is so important. If you have a fever and your temperature goes up, there's too much disorder in the system because the water molecules are now moving so quickly that they're bumping all the other molecules all over the place. But if you freeze it, everything stops. That's not good either. So you need this quenched disorder, this limited randomness, and in our bodies, that's partly established by what your body temperature is. So a cell ceases to exist when you go down to the nanoscopic level. It's just a bunch of molecules in water. So are molecules then the fundamental thing? Well, they're just atoms that are self-organizing into molecules. And what are atoms? Well, they're just self-organizing particles, the electrons, protons, neutrons. Well, are those the fundamental thing? Well, no, there's another layer of elementary particles, the standard model, below that. Are those the fundamental thing? Well, no, there's another level below that. And physicists don't agree on what those things are. Strings is one theory, and that's why string theory is so popular, because that's one thought. But it's not turtles all the way down. There isn't endlessly smaller things. One thing physicists agree on is that there is a smallest distance and a smallest unit of time. They're called the Planck distance and Planck time. And things can't get smaller than that. So when you get to these smallest things, whatever they are, strings or whatever, are they the fundamental thing? It turns out they're not. The vacuum that we measure by space-time is not actually empty the way we think vacuums are. It's an extremely high energy field. And because E equals mc squared, the energy in that field is constantly turning into little tiny particles or strings or whatever. Most of those form in matter-antimatter pairings, and so they just self-annihilate. So energy bubbles up in what's called the quantum foam. I really like that term. So you have this foam of energy turning into matter-antimatter stuff, and it's just bubbling and bubbling. But every once in a while, some of those things don't actually self-annihilate, and the particles that don't self-annihilate can interact with each other in exactly the same way we were talking about the paramecium. So strings, or whatever the smallest things are that escape the subsiding back into the vacuum, they interact with each other to create quarks and such stuff. And they interact with each other to create atoms, and those interact with each other to create molecules, and on up through the universe. So the entire universe then is a self-organizing system. And there is no thing that you can identify that is independent, permanent, existent in and of itself. And this is what the Buddhists call emptiness of inherent existence. At this level of scale, I look like a body. Lower down, there's no body at all. I'm just a community of cells that are self-organizing, most of which aren't even human. Most of them are bacteria. So, and those cells, when you go down even lower, they don't exist either. They're just a bunch of molecules self-organizing in water. So this self-organization and the randomness that makes things alive is a feature of the universe. It's not just a feature of ants or cells. There's nothing that isn't like that. And then it turns out that maps very concretely to things like Buddhist metaphysics, Jewish and Hindu mysticism, and that's where things start to get interesting. One of the issues is raised by quantum mechanics, the experiments where how you decide to do an experiment, light will turn out to be either made of waves or particles. And it's not the light making a decision, it's you choosing the experimental method, and that will reveal one thing or the other. And, initially this was thought to be just our lack of understanding. But it turns out that no, the conscious decision of making a measurement, of observing anything, determines to some extent what form that thing will take, or what form that process will take. Because as we already saw, things are just processes really when viewed from a different perspective. So dealing with this, the quantum physicists, Max Planck, Niels Bohr, Heisenberg, some of the greatest minds we've ever had, came to the conclusion that consciousness couldn't be taken out of the system. The universe was not a machine that functioned outside of the act of observation, that all we have is our observation, our conscious observation, and made by a conscious choice of how to observe. So then Planck himself said, we can't get behind consciousness, meaning that matter and energy and space and time are things that follow from conscious observation. They don't actually precede that, which is against our standard cultural model these days, which is to say, which looks as bodies as machines. And I've already said, they're not machines. Machines don't have randomness in them. If we're alive, we're not a machine. But they want to look at that and go, the brain is a machine which produces mind. But just as reasonably, and in fact there's an imperative because of the quantum mechanical phenomena, to say just the opposite, that mind is what's necessary to create the universe. And then that turns out to reflect a very, very strong thread of Western philosophy that, since people generally don't study philosophy very much, they've heard the names, but they don't know what it means. So Plato, Spinoza, Kant, Hegel, they were all of the view that the universe was made of a single substance. Spinoza's my favorite, he referred to the world being made of one substance. What is that substance? Kant and Hegel are moving in the direction of saying that one substance is mind itself, consciousness itself. The opposite view, which comes from a group of philosophers called the Vienna Circle in the 1920s and 30s in Vienna, their project was to show how the entire universe could be described mathematically, and that any formal system of mathematics, if done right, could explain everything. In other words, the world is a machine and you can show mathematically what it's going to do. And so they declared that the only things we could know are things you could deduce logically as part of a formal axiomatic system, as they said, or things you could experiment and test in the world. And anything else, like mystical experiences, you can't even talk about it. You can't test it, you can't deduce it from a mathematical system, therefore it's even off limits. It's not a phenomenon, it doesn't exist. Which is strange because quantum physics and relativity had already established themselves showing that observations change the nature of things, that there is no way to do a formal experiment that always shows exactly the same thing. There is randomness in the way the world puts itself together, and mind is involved in that. And yet that became our dominant view, culturally, to the point where people don't even know who the Vienna Circle philosophers were. They've never heard of logical positivism, but they know that science means you deduce things mathematically or you do experiments, and that's the only way we can assess what's real. But Plato, Spinoza, Kant, and Hegel clearly thought otherwise. And one of their own, a mathematician, philosopher named Kurt Gödel, famous for Gödel's incompleteness theorems, actually showed that their whole project of mathematization was wrong. Because if you had a formal system the way they intended to build them, if it was complete, it would by necessity contradict itself. And that means it has no logic. And if it is fully consistent with itself, then it's not complete, which means there's always something outside of it unexplained. And so from within their own system, their system fell apart, logically. But our culture still breathes that air, that everything should be formal, everything should be mathematical, everything is a machine that's deducible. And our experiences, like the taste of chocolate, the color red, these are, you know, the ones people usually pick up on at conferences like this. That we can't discuss. Driving some philosophers to say even that experiences don't exist, even though that's all we have. So what is, if the quantum physicists say mind is inherent, and we can turn it on its head and say, well, maybe awareness is all there is. Perception, knowing, is all there is. And out of that, the universe arises. Out of that, space and time arise, and matter and energy arise. And so the question of where does the experience of red come from, or where does the taste of chocolate come from, those we refer to as qualia. And the hard problem of consciousness everyone talks about is how to explain qualia. Well, if everything arises from mind, then everything in the universe is qualia. It's not that there's a universe and then qualia happen in it. Everything in the universe is qualia. This chair is qualia, my body is qualia, my mind is qualia. The person listening to this is qualia. Every electron, every photon. So the hard problem disappears because there isn't anything but qualia. And this is exactly what Jewish mystics, Hindu mystics, Buddhist contemplatives, shamanic practitioners, all of these are reporting that when you get to the fundamental experience of the nature of the universe by going inward, what you find is there's nothing but pure perception, pure knowing, pure awareness. And that's the nature of things. So somehow going from stem cells and wondering how they're like ants, we get to what's the nature of the universe. I've been working with Minas Kafatos on how to think about this. His own particular spiritual practice is Shaivism. And their view, the different contemplative traditions are usually asking very specific questions. So the information they reveal is often different. So the question in Jewish mysticism is often, how does God create the world? And so that's what they're exploring. In Buddhism, what's the nature of suffering and how do we put an end to suffering? So that gives you a different set of results. They're all interrogating the universe using the mind, but their questions are different. The Shaivists got very down into the detail of how does that perception give rise, that pure awareness give rise to differentiation, things that are different from each other. And so what we think is happening is that you start with this field of pure awareness, and there is a sense within it that there is the I that perceives, and then there is an object of perception. But at this point, that object and the I are the same. But there's sort of a tension there, because in the vast space beyond time and space, that's just stasis. There's no action. There's nothing happening. So there's a little bit of a movement and a little bit of separation between the I and the that. So that they're still the same, but there's a recognition within that perception that there are different ways of thinking about it. There are different ways of knowing it. And as that separation starts to become reified, then the perceiver starts to perceive something else. And as that develops into, and this is tricky to talk about, language isn't very good at this. As those separate into object and subject, that's when the world starts to arise. And the moment you have a separation into object and subject, separation implies distance, space. The act of observation and then processing that information from the observation and responding to it, that implies time because it's a process. So space-time has happened. And out of space-time comes energy and matter. And so it's through this separation of this pure awareness into an object and a subject that the world necessarily happens. You could ask, would it be possible for it to just sit there without doing that? It's its nature to do that. This is where we start talking about complementarity. So it's sort of like those images where you have two faces that are looking at each other and the space between them looks like a vase. And you can see the faces or you can see the vase. And you know it's both, but you can only ever see one at the same time. So that pure awareness is like maybe the vase, and the faces are the object-subject duality. And so duality and non-duality are always in interplay with each other. One implies the other. If you see the non-dual, it implies there was a duality if you see duality, it implies there's a non-dual from which it arose. If you're experiencing the non-dual, you have to know that there is a duality beyond that. In Buddhist terms, nirvana is not transcending into the non-dual, it's coming back into the duality, the world of dualities, and realizing this itself is that perfection, because they're the same thing. But you can only see one or the other. You can't see them both simultaneously. So that pure awareness necessarily always creates. And what it creates, because it's self-organizing, there's randomness, as we've described, we know those features, it's always alive, it's always conscious. There's nothing that isn't alive, there's nothing that isn't conscious. Clearly I'm a nerdy science geek, and I always have been. But I come from a family with a very strong Jewish practice. On my mother's side, a lineage of rabbis and mystics going back centuries. And as much as my mom's generation was not well schooled in that, still it filtered down. And I grew up, my parents are European, my father's from Germany, and so the Holocaust was sort of just over our shoulders growing up. So the question of suffering was a big thing. How could that happen? So religion wasn't easy. There was already a struggle inherent. If I'm being brought up in a religious family, and a warm one, it wasn't dictatorial, it wasn't manipulative, it was actually a very positive thing. I enjoyed practicing my religion within my family, within my community. And yet there was this knot of doubt because the Holocaust had just happened and my grandparents were killed, many of our relatives. And at the same time, I just had this sort of innate sense of something about the world being something one related to. It wasn't a place in which we live. It was a set of relationships. One story that got told often by a distant cousin who was sort of a substitute grandmother for my brother and I. We were walking in our neighborhood. She was in her 80s and I was like 7 years old. And there was this lawn with lots of dandelions in it. And there was this one dandelion that was huge and bright yellow and really beautiful. And she said, "Would you go pick that for me?" And I was like, "Oh, Tante," aunt in German, "Tante Russin, I can't do that. I'd have to kill it. You don't want to do that, do you?" So I had this sense, I would even feel bad if I kicked a rock and it fell in a sewer. I was like, oh, the poor rock. I shouldn't have kicked it. So proto-Buddhist or something. And the divergent ants. My mother was obsessed with ants getting into the house. And she'd be like, get that ant out of here, kill it, we've got to call the exterminator. And she was right, because those ants that wandered into the house were the divergent ants that would build a food line right into the house. So she knew this stuff, but I would go carry the ant out on a piece of paper because I can't kill it. So I had this sort of sense, and that became my interest in science eventually. So the science stuff started, I think, as a spiritual practice, though I wouldn't have labeled it as such. It was just a naturally spontaneous occurring sort of thing. But then on the religion side, how to make sense of the Holocaust. And at some point I became aware of mystical traditions. So I became aware at when I was 14 of Jewish mystical traditions, which I hadn't learned anything about. And it gave me the idea that, it was possible through meditation to have a view of the world from God's perspective. That's the way I interpreted this, rather than our own perspective. And I thought, maybe from God's perspective, the Holocaust would make sense. If I had the God's eye view, it would solve the problem. But at that time, this was in the early 70s, Jewish mysticism was sort of off limits for a non-Orthodox kid growing up in the suburbs. And when I got to college, I discovered Zen Buddhism. And that seemed at the time like kind of a non-theist, non-deist way to meditate in a serious fashion without having to bring God issues in that would contradict the Jewish stuff. So I became a Zen Buddhist. And was content to let the science path and the spiritual paths just be separate. I had no particular urge to merge them until they just started merging sort of spontaneously. When I was sitting in the Zendo in New York City. I used to be responsible for opening it for Thursday morning, and Thursday morning I was there alone back in those years. And I remember sitting there thinking, my body is made of stem cells and they're moving around, and what does that mean? And I looked up from where I was sitting opposite the altar and saw the incense stick turning into smoke. And suddenly had a very vivid experience of, that's what my body is. And that's what happens when you die, maybe. It's like the incense stick turning into smoke. This is emptiness of inherent existence. My body is both a body and not a body. It's a phenomenon arising from cells. Everything is a phenomenon arising from something else that only looks like a thing. And that was the moment where the two things started to merge together. I wasn't looking for it, but it just sort of like, after a few decades of cultivating each, it turned out I was cultivating the same thing on both sides.